Solving logarithmic equations. So similar to solving exponential equations, logarithms are kind of around the same way. Since these are inverses of each other, they work pretty close together. So here's the algebra speak for this property of equality that we're going to need. So if b, x, and y are positive real numbers and b is not equal to 1, then that means log base b of x is equal to log base b of y if and only if x and y are equal. So here's an example. Let's think of what this actually says. So if log base 2 of x is equal to log base 2 of 7, then that means that the log's arguments, the stuff inside that logarithm, are also equal to each other. X equals 7. And I can go backwards as well. If x is equal to 7, then I can make x the argument of a log with a certain base equal to 7, the argument of a log with the same base. There's also this inverse property that we need to know. If I have an exponent and the base is b and its exponent is log with that same base, then, well, what happens is the base and the log kind of cancel out, and all you're left with is what the argument is. Whatever's inside, that's all you're left with. So let's solve some of these. So step 1, rewrite the problem using only one log on both sides of the equal sign. So number 1, solve the natural log of 4x minus 7 equal to the natural log of x plus 5. So both sides have one log. Step 1's good to go. Step 2, rewrite the problems without any logarithms. So there's two choices here. If you have 2 logs total, then that means you're going to use the equality property above. If you have 1 log and only 1 log, change it to exponential form. So for this example 1, we have situation A, where we have 2 logs, one on both sides. So now they're both natural logs. That means their bases are both an e. So since it's a log with the same base on the left and the right, that means I can take their arguments and set them equal to each other. 4x minus 7 equals x plus 5. I can drop the logarithm portion. And then we're just going to continue to solve this like a regular equation. So I'm going to subtract x from both sides. So I get 3x minus 7 equals 5. Add 7. 3x equals 12. And divide by 3, x is equal to 4. Now, with logarithms, you have to check and make sure that you don't have a negative inside of a log. So before you stop and say, boom, there's your solution, you're going to have to go back and check. So we're going to substitute in 4 where x is. So 4 times 4 minus 7 equals natural log of 4 plus 5, and make sure I don't have any negatives inside the logarithms. So on the left, 4 times 4 makes 16, and 16 minus 7 makes 9, so that's a positive number, so that's good. And then on the right, 4 plus 5 also makes 9, that one's positive as well. So since both arguments are positive, that means yes, x equals 4 is in fact the solution. You always have to check, because you cannot take logs of negative numbers. The x's have to be greater than or equal to 0. Example 2. Log base 2 of 5x minus 17 equals 3. So step 1 above says make sure that there's only one log on either side. So in this case, I only have 1 log, so step 1's good to go. Step 2 is rewrite the problem without any logs. So in this case, I have that situation B. I only have 1 log in this equation. So that means I'm going to have to change this into exponential form. So the way we do that is start with the base, raise it to the number across from the equal sign. So 2 to the third is equal to, and then the argument, whatever's inside the logarithm. So 2 to the third is equal to 5x plus 17. Now that we've written this without a log, we're just going to continue solving. So 2 to the third is equal to 8. 5x minus 17. Add the 17 to both sides. So we end up with 25 equals 5x. Divide both sides by 5, and we end up with x is equal to 5. But again, before we can say that yes, this is my final solution, I need to make sure I always go back and check and make sure I don't end up with a negative inside the logarithm. So log base 2 of 5, x is now a 5, minus 17. So 5 times 5 makes 25. 25 minus 17 makes an 8. So log base 2 of 8 equals 3. The 8 is what is the problem. So since 8 is positive, we are good. And that does mean x equals 5 is the solution. Example 3. Natural log of 4x minus 1 equals 3. So step 1, rewrite the problem only with one log. That's not a problem in this case because I only have one natural log. Step 2, write the problem without any logs. So again, I have that letter B situation. I only have a single log to work with, so I need to change this into this exponential form. So we have to remember that natural logs have that hidden base of e. So we're going to take that base of e to the third. So e to the third equals the argument, 4x minus 1. And now we're going to continue solving. I'm going to go ahead and use my calculator to get a decimal approximation for e to the third. So I have about 20.086. Then I'm going to continue solving, add 1 to both sides. 21.086 equals 4x. And then divide by 4 on both sides. X is equal to 5.272. And again, we do need to check and make sure that this is not going to give me a negative number. So here's my check. Natural log of 4 times 5.272 minus 1. Well, 4 times 5.272, that's going to give me 21.086. Subtract 1, which is 20.086, which is definitely positive. So yes, 5.272 is my solution. Example 4. Solve log of 2x plus log of x minus 5 equals 2. So step 1 is I need to get a single log on either side. So I have 2 logs in this case. So I'm going to have to use my properties of logarithms to condense this down into a single log. So I see that these logs are being added. So that means I'm going to use the product property and multiply the 2x and the x minus 5 inside my logarithm. So these condense down into log of 2x times x minus 5 equals 2. Now before I mess with this any further, I'm going to go ahead and simplify this inside. So 2x times x makes 2x squared. 2x times negative 5 makes negative 10x, and then equals 2. So now I have to get rid of my logs, and I only have one log, so that means I'm going to have to use the exponential form. So log without bases really has a hidden base of 10. So 10 to the second power is equal to the argument, equal to 2x squared minus 10x. Well, I see that I have an x squared here, so I'm going to have to solve a quadratic equation. So 10 squared is 100. Then I need to move that 100 to the other side with everything else. So I have 0 equals 2x squared minus 10x minus 100. So I'm going to have to solve this by factoring or quadratic formula. Well, before I do either one of those, I see that all of these can be divided by 2, so I'm going to divide by 2 on the entire equation. 0 divided by 2 makes 0, 2x squared divided by 2 makes x squared, negative 10x divided by 2 makes negative 5x, negative 100 divided by 2 makes 50. So I'm going to have to do this by factoring. Well, since a is equal to 1, I can do my shortcut and just go ahead and set up my factors and find the two numbers. So I need numbers that multiply to a negative 50, but add up to be negative 5. Well, those two numbers are going to be negative 10 times a 5. Negative 10 times 5 makes negative 50, and if I do negative 10 plus 5, I get negative 5. Set each factor equal to 0, and then solve each factor for x. So I get 10 equals x, and on the other equation we have negative 5 equals x. Now remember, we can't assume that both of these are solutions. We have to make sure we check them and that we don't have any negatives inside of our logs. So I'm going to use the original equation. So I have log of 2x. I'm going to check the 10 first. So log of 2 times 10 plus log of 10 minus 5. Well, 2 times 10 makes 20. That's positive. Log of 10 minus 5 makes 5, which is also positive. So that means that x equals 10 is a good solution. Now let's check the other x. log of 2 times x is negative 5 now, plus log of negative 5 minus 5. Well, 2 times negative 5, that's negative 10. There's already a negative inside of a log. That means that negative 5 cannot be a solution. So the only solution to this equation is x equals 10. Example 5. Solve log base 4 of 2x plus 1 equals log base 4 of x plus 2 minus log base 4 of 3. So step 1 is getting everything down into a single log on both sides. So my left-hand side of the equation is ready to go. There's only one log. That one is perfectly fine. On the right, however, I have 2 logs. So I need to use my properties of logarithms to condense this down into 1. So I see there's a minus in between. That means I'm going to have to use the quotient property and divide the arguments. So x plus 2 over 3 inside of a single log. Now that everything's condensed, step 2 is I'm going to have to get rid of the logs. Well, I have 2 logs on both sides, both with the same bases. So that means I can take their arguments and set them equal. So 2x plus 1 equal to x plus 2 over 3. So I'm going to solve this by using cross multiplication. So 2x plus 1 times 3 equals 1 times x plus 2. So let's simplify this down. 3 times 2x makes 6x. 3 times 1 makes 3. 1 times x makes x. 1 times 2 makes 2. Subtract x from both sides. 5x plus 3 equals 2. Subtract 3. 5x equals negative 1, and then divide by 5. So x is equal to negative 1/5. So remember, we need to check and make sure that this negative 1/5 is not going to make a negative inside any of my logs before we can say that this is the answer. So I'm going to check each log individually. So the first log was 2x plus 1. So 2 times negative 1/5 plus 1. Let's check that one. So this is going to be negative 2/5 plus 1, and negative 2/5 plus 1 makes 3/5, which is positive. So far, so good. The next log that had a variable in it was log base 4 of x plus 2. So x was negative 1/5 plus 2. Negative 1/5 plus 2 makes 9/5, which is also positive. So yes, x equals negative 1/5 is a solution.